let's go to the book, and I'm in chapter 2, lesson 6, which is called, what is it called? Differential equations with separable variables. So your textbook has laid a lot of groundwork in this chapter, and but going to get right to the point here in lesson 6. I'm on page 56, and this is problem number 6. So I'm going to read it to you because just to make sure you can read my writing, so I'll tend to read the problems to you. Yx squared dy minus y cubed dx equals 2x squared dy. Alright, well, this is the differential form of a differential equation because we don't have a y prime or dy dx, we have differentials, dx's and dy's. And the advantage of this form for this type of problem is that our strategy involves separating the x's from the y's and then integrating both sides of the equation. Alright, now if that's could be done with every problem, then that would be pretty much the end of the story for differential equations. But most equations we come across, we can't separate x's and y's algebraically or some other means, so we have to devise other methods. But when it's possible to separate x's and y's, then it's just a matter of integrating both sides at that point, and you can finish up. Alright, so I'm going to transfer the dx term to the right side and this dy term over to the left side with the other dy term. So I've got y x squared dy, subtract this term, minus 2x squared dy, add this term, y cubed dx, and over here x squared and dy factor out, so I can write this as x squared parentheses y minus 2, and then dy equals to y cubed dx. So I factored here in order to make the separation easier. So I want to have nothing but y's on the left side, so I'm going to divide both sides by x squared and divide both sides by y cubed. So that gives me y minus 2 over y cubed dy equals to dx over x squared. Alright, so through algebra means we separated x's from y's and the differentials as well. Now your differentials have to be numerators. You can't divide by a differential and expect to do anything with it. But at this point we can take care of the differentials by integrating both sides. So we'll integrate. Now to make this a little easier to think through, over here I've got y minus 2 over y cubed. I'm going to divide y to the third power into both these terms and write it this way. So this y over y cubed is y to the minus 2 power, and then minus this 2 times y to the negative third power dy. On the right side I'm integrating x to the minus 2 dx. So that will probably make the antiderivatives a little easier to go through here. Alright, well, I'll have to do a lot of erasing for all these videos because these problems can get long. This one's actually a fairly short problem compared to some of the problems that we'll be working. Let me try another blue pen here, see if it writes a little better. Alright, so if we integrate y to the minus 2, we'll get, add 1 to the exponent, divide by the new exponent. I have y to the minus 1 over negative 1. That's negative y to the minus 1. Add 1 to the this exponent, it's y to the minus 2, divide by minus 2, minus 2's cancel, plus y to the minus 2. On the right side, we'll get minus x to the minus 1. And somewhere I've got to put the plus c, the plus constant. And so that's pretty important in these differential equations, these additive constants. So you might remember from a beginning calculus when you started integrating, the antiderivative, when there are no limits of integration, produces a whole family of solutions, or a whole family of antiderivatives. And so when we integrate without limits of integration, we always write a plus c, plus a constant. Both of these would give you a constant, But if we combine constants together, we get one constant. So it's only necessary to put one constant in there when we integrate. All right, it's also a good idea to check your integration. You made so many people make mistakes by not taking a minute to check. So if I take these derivatives, I should get this. So this is, the negatives cancel. Minus 1 times negative is positive 1, y to the minus 2. Okay, that checks. Negative 2, y to the minus 3, that checks out. Plus x to the minus 2. So the integration is correct. And of course the derivative of constant is 0. All right, now we have kind of a dilemma. How are we going to write the answer? And this is really 1 over y, minus 1 over y plus 1 over y squared equals to minus 1 over x plus a constant. That actually is a solution to this problem. And but our textbook, I looked earlier, our textbook doesn't leave it with any fractions, and so they cleared the fractions. You can do so by multiplying the cross by the common denominator, x, y squared. So in doing that, we're going to get minus xy over here, minus xy plus x equals to minus y squared plus cxy squared. All right, and let's see, let's do a little factoring. I'll pull the x out. Pull the x out, I'll have a 1 and then a minus y. 1 minus y. And here, pull the y squared out. I have cx minus 1. So, now, that's not the exact form the textbook had. I looked ahead. And so what they did was to multiply everything by negative 1. So if you distribute the minus 1 through this parentheses, it's going to reverse the 1 minus y. It'll be a plus y minus 1. So that gives me x parentheses y minus 1. And on the right side, if I multiply the minus 1 through here, I'll get a 1 minus cx times y squared. But then the textbook did another little neat finesse. It's c is a constant. So if I make this a plus, it's still a constant. It just changes my constant a little bit, but it doesn't matter. And so this actually is the form the book has, with one other little provision here. When you look up here, you say, well, both x and y cannot be 0, because if they were, we would have division by 0. So we should also say that x does not equal 0, y does not equal to 0. Alright, so there we go. There's our full answer, and I believe that matches the textbook answer. So that's going to be an issue for you. You work a problem, and you might do it right, but your answer will look different from the textbook, because you may have to do a little bit of algebra just to confirm that you got their answer. You match their answer. So it just goes with the territory in this course. You may have to do a little more extra algebra to make sure you got the right answer. All right, well, let's do another problem.